Okay, question 5 is a whole bunch of problems asking us to solve for x. So everyone's standard operation that you do in different courses in high school. Solve for x. Find the value of x and make something happen. And the rules, there's really just one rule for solving for x, and that's if you have a statement that's equal to another statement, you want to manipulate that pair of statements by doing the same thing to both sides. Whatever you do to the left side, you want to do to the right side. Beyond that, it's a matter of imagination and strategy. For example, in this first problem, we can multiply both sides by 6 if we want. It doesn't help us find x, but we're allowed to do that. We could add 10 to both sides, so we'd have 3x plus 17 is equal to 29. Again, it doesn't help us find what x is equal to, but it doesn't violate rules of math either. The most important thing is that when you're manipulating an expression like this, when you're trying to isolate for part of an expression, if you do something to one side, you have to do it to the other side. My first move is I'm going to subtract 7 from both sides. So 3x plus 7 minus 7 is equal to 19 minus 7. So 3x is equal to 12. Then I'm going to divide both sides by 3. So I'll have 3x over 3 is equal to 12 over 3. And that means x is equal to 4. So that'd be our solution for part A. Part B, we're going to follow the same strategy. We have 3 over x plus 1 is equal to 3. I'm going to begin by subtracting 1 from both sides. So 3 over x is equal to 3 minus 1. So 3 over x is equal to 2. Then I'm going to multiply both sides by x. So cross multiply. So 3x over x is equal to 2x. On the left side, the x's cancel. So we get 3 is equal to 2x. We can then divide both sides by 2. And we get x is equal to 3 over 2. So that'd be the answer for that question. So quite a few moves were needed to isolate for x here. We had to subtract, we had to cross multiply, and then we had to cross divide. The next problem is very different than these two. 2 to the power of x is equal to 8. So this time we're not manipulating in the exact same way. I'm going to use a trick. I'm going to note that 8 can be written as 2 to the power of 3. Thus, the question can be rewritten as 2 to the what is equal to 2 to the 3. Now this looks really silly. 2 to what number is equal to that number? Well, the what must be equal to the that. X must be equal to 3. This question takes on a very different characteristic if the number on the right-hand side is not 2 to some power. So if the question was 2 to the x is equal to 7, we would need log functions to answer that. Okay, next problem. We have a cubic. 6x cubed plus 12x squared minus 18x is equal to 0. The best way to solve cubics, quadratics, or any type of polynomial expression being set equal to 0 is to make sure everything's on one side. Don't divide. Just bring everything across by adding and subtracting. Then common factor. And then factor any remaining quadratic or cubic. So I'm going to common factor a 6 out of the expression and an x out of the expression. And what we're left with is x squared plus 2x minus 3. So far we know one solution. We know that x equals 0 is the solution from the first term in that expression, the first part of that product, 6x. If that term is equal to 0, then the whole thing is 0. And 6x is 0 if x is 0. But we have to continue because there might be solutions hiding in that bracket, the x squared plus 2x minus 3. So I'm going to try to factor this. There's many strategies for factoring. I'm going to use a product and sum method. I want numbers that multiply together to give negative 3, add together to give positive 2. And let's see. So I can do a plus 3 and a minus 1. Those add together to give the positive 2, and then multiply together to give the negative 3. Now look at the whole thing. This tells us there's 3 solutions. X is equal to 0, from the first part of the product being 0. X is equal to negative 3. For the second part of the product, x plus 3 being equal to 0. And x is equal to 1 from the last bracket being 0. So 3 solutions. 3 solutions came out. You could also check. So I'll check the last one. I'll check x is equal to 1. Plug in 1 for x. We get 6 times 1 cubed plus 12 times 1 squared. So that's 6 plus 12, 18. Minus 18 times 1. 18 minus 18 is 0. So yep, that one worked. I don't really want to check the negative 3 because that'll be a 6 times negative 27 plus a 12 times 9 minus an 18 times negative 3. I don't want to do all that. That sounds like too much work. So I'll just, check one of them and then assume the rest are right. Okay, part E. 3x squared minus 12x is equal to x squared plus 5x. Please don't divide by x. If you divide by x, you're throwing away a solution. Begin by bringing everything to one side. I'm going to subtract x squared from both sides. And I'm going to subtract 5x from both sides. And then I'm going to collect like terms. 3x squared minus x squared is 2x squared. And negative 12x minus 5x is negative 17x. Okay, next step. I'm going to common factor an x out. And continue that up here. X times 2x minus 17 is equal to 0. This is a little bit harder to solve. I'm still going to set each product in this expression equal to 0. So the first product is just x. Well, if x is 0, then the whole thing is 0, so that's the solution. And the second, I am setting 2x minus 17 equal to 0. You can do that. Do that over here. 2x minus 17 is equal to 0. So 2x is equal to 17. X is equal to 17 over 2. There you go. So there's your 2 answers for that one. Okay. Part F. 3 to the power of x is equal to 5. Well, 5 is not a perfect power of 3. 3 to the power of 1 is 3. 3 to the power of 2 is 9. There's no other whole numbers that are in between. So what I'm going to do is I'm going to use logs. So we need logs for this problem. I'm going to take ln of both sides, natural log base e. Ln of 3 to the power of x is equal to ln of 5, where ln means log base e. So the log function with a special base, special number e, 2.71828. This particular log function, the ln function, is going to come up a lot inside calc1000. Okay, the next step is I'm going to use that log property that was discussed in the true-false questions. If we have a log of an argument raised to a power, we can bring the power down. So x times ln of 3 is equal to ln of 5. And then we can divide both sides by ln 3. Now we get x is equal to ln 5 divided by ln 3. As a special note, ln 5 over ln 3 does not equal ln of 5 over 3. You cannot do that. You can't bring the arguments together into one log function like that. Instead, ln of 5 divided by 3 is ln of 5 minus ln of 3. It's one of the other log rules. there's a separate worksheet for exponential and log expressions. Can't put everything in one sheet. It's like 2 high school courses. It's 10 months of material. Okay, part G. Solve for x of log base 2 of x is equal to 5. Now, the way I'm going to describe this is not likely the way that was taught to you in high school. It wasn't taught to me in high school this way. But think about the mathematical rules that we're allowed to do to an expression something equals something else. We can add the same thing to both sides. We can subtract something from both sides. We can multiply both sides by the same thing. We can divide both sides by the same thing. If we're really careful, we can take the square root of both sides, or we can square both sides. There's some operations that we're allowed to do to both sides of an expression. One of them that's not often described in high school is exponentiation. I'm going to exponentiate. Which means raise both sides as powers on the same base. I'm going to use a base of 2. The reason I'm using a base of 2 is because the log function has a base of 2. So this is what happens. 2 to the power of log base 2 of x is equal to 2 to the power of 5. On the left-hand side, 2 to the power of log base 2 of x, we can use something called the cancellation law. And I don't know if this is review for you. It might not be review. That's part of the curriculum in the Ontario high schools, and I believe it's part of the curriculum in most Chinese high schools and most schools in the science stream, mathematics in India and a whole bunch of other countries. But not every teacher in every school covers everything that is in the curriculum. So it might not be review. Okay, now the right-hand side, 2 to the power of 5 is not 10. It's 2 multiplied by itself 5 times, and if you do that, you'll get 32. That's the answer. So log base 2 of 32 is equal to 5. In part H, we're going to do the same thing. We're going to exponentiate. Remember that ln means log base e. So I'm going to exponentiate both sides as powers on a base of e. So we have e to the ln of x equals e to the 5. Now, e to the ln of x equals e to the power of log base e of x. You use the cancellation law, we just get x. So we get x is equal to e to the 5. This is just a number. You could plug that into a calculator and get the number for that out if you wanted, but in this course, we'd leave it alone. We just call it e to the power 5. 2.71829 ... infinitely repeating string of decimals, e, multiplied by itself 5 times. Okay, question I starts in a similar way to question G. We have the unknown, the x, trapped in a log function. We want to get it out. To get it out, we're going to have to exponentiate. On base 2. Notice I just keep shortening my explanation for what we're doing in the operation. We're exponentiating to a base, or on a base. I'm using base 2 to match the base of the log. 2 to the power of log base 2 of 3x minus 1 is equal to 2 to the power of 3. I have to do the same thing to both sides. On the left, there's a cancellation law. I should attach the word law to this. This is a special law essentially how exponential functions and log functions are defined through the cancellation law. So what we're left with on the left is just the argument of the function, 3x minus 1. On the right, we have 2 to the power of 3, which is not 6. It's 2 times 2 times 2, which is 8. I'm going to add 1 to both sides. So 3x is equal to 9. Then divide both sides by 3. So we get 3 as the answer. And all of these we can always check. We can check if what we have is correct. Log base 2 of 3x minus 1 equals 3. Log base 2 of 9 minus 1 is equal to 3, replacing x with 3. Log base 2 of 8 is equal to 3. And 8 is the same thing as 2 to the power of 3. We have a cancellation law here. And we get 3 equals 3. So it worked. Left-hand side is equal to right-hand side. Okay, J. We have a few manipulations to do before we exponentiate to get the x out of the log. We only exponentiate once the log is all by itself. So our first step here is to isolate for the log. The first thing I'm going to do is subtract 7 from both sides. 2 times the ln of 3x minus 5 plus 7 minus 7 is equal to 15 minus 7. So 2 times the ln of 3x minus 5 is equal to 8. Then I'm going to divide both sides by 2. So ln of 3x minus 5 is equal to 8 divided by 2, which is 4. Now I'm going to exponentiate to base e. So e to the ln of 3x minus 5 is equal to e to the power of 4. E to the power of ln means e to the power of log base e. We have a cancellation law here. So we have 3x minus 5 is equal to e to the power of 4. And remember, we're trying to get x all by itself. So I'm going to add 5 to both sides. So 3x is equal to 5 plus e to the 4. And then divide both sides by 3. And we get our answer. X is equal to 5 plus e to the power of 4 all over 3. It's a lot of work. Okay, now the next problem, we escape from logs and exponentials. We get back into fraction expressions. 3 divided by 2 plus x is equal to 5. And begin by cross multiplying. So 3 is equal to 5 times 2 plus x. We distribute the 5 through the bracket. So 10 plus 5x on the right. Now we want to get x all by itself. So I'm going to isolate next by subtracting 10 from both sides. So 3 minus 10 is equal to 5x. So negative 7 is equal to 5x. And then divide both sides by 5. So x is equal to negative 7 over 5. That'll be our answer for that one. Okay, the next problem, problem L, is almost identical. We're going to follow the exact same steps. We'll begin by cross multiplying. So 3 is equal to 5 times 2 plus x to the power of negative 1. Multiply the 5 through the bracket. So 10 plus 2x to the power of negative 1. Subtract 10 from both sides. So negative 7 is equal to 2 to the power of x minus 1. Make it look as similar as I can. So x to the power of negative 1, we're going to divide both sides by 2. Oh, sorry, not 2. Why did I put 2? This is when if this was in person, someone would put up their hand. So we were in the classroom doing this, instead of me just making a video. Someone put up your hand. Why is it 2? Why not 5? Okay, so I'm going to divide by 5. So x to the power of negative 1 is equal to negative 7 over 5. Now be careful. Power negative 1 does not mean negative x. Note, x to the negative a means 1 over x. 1 over x to the positive a. So x to the negative 1 means 1 over x. So what we have right now is we have 1 over x is equal to negative 7 over 5. Then cross multiply, cross divide, we get x is equal to minus 5 over 7. Okay, question M. Very similar to the above. Cross multiply. So 3 is equal to 5 times 3 over x plus 5. And distribute through the brackets. 3 is equal to 5 times 3 over x, so 15 over x plus 25. And then subtract 25 from both sides. So negative 22 is equal to 15 over x. I'm going to continue up above. Let's cross multiply by x. So we have negative 22x is equal to 15x over x. X's cancel on the right. So negative 22x is equal to 15. And then divide both sides by negative 22. So we get x equals negative 15 over 22. Negative signs, if they're in the bottom, can be brought up top, or they can be brought in front. It doesn't matter. I'll just immediately bring it up top. Okay, and then the next question, we launch into trigonometry. I'll break the video here and then continue with another video.